Ever wonder why it's summer in Australia when it's winter in Canada? Let's unlock the mystery behind the changing seasons and why they flip between northern and southern parts of our planet. Ever wonder why it's summer in Australia when it's winter in Canada? In today's video, we're clearly explaining why seasons change between hemispheres. Let's unlock the mystery behind the changing seasons and why they flip between northern and southern parts of our planet. Hello, and welcome to today's explainer. Our topic is a fascinating natural phenomenon that shapes life on Earth. Why seasons change between the northern and southern hemispheres. It's a question that often surprises people and gets us thinking about the relationship between our planet and the sun. Let's dive deep into the science behind this cycle and discover how the tilt of Earth and its orbit around the Sun create the seasons. First, let's establish what we mean by seasons. Seasons are distinct periods of the year characterized by changes in weather, temperature, and daylight hours. Most regions around the world experience four main seasons: spring, summer, autumn, and winter. However, these seasons don't occur at the same time everywhere, especially when you look at the difference between the northern and southern hemispheres. So why exactly do seasons change between hemispheres? The main reason lies in the Earth's axial tilt. Imagine a spinning top that leans slightly to one side. Our planet Earth spins on its axis, but unlike a perfectly upright top, Earth is tilted at an angle of approximately 23.5 degrees relative to its path around the Sun. This tilt is the critical factor that causes seasonal variations. As Earth revolves around the Sun over the course of a year, different parts of the planet receive varying amounts of sunlight. When the northern hemisphere is tilted toward the Sun, it experiences more direct sunlight and longer daylight hours, creating warm temperatures or what we call summer. Simultaneously, the southern hemisphere is tilted away from the Sun, getting less direct sunlight and shorter days, which means it is winter there. Half a year later, the situation reverses. The southern hemisphere tilts towards the Sun, enjoying summer, while the northern hemisphere moves into winter. To put this in perspective, think about June and December. Around June 21st, which marks the summer solstice for the Northern Hemisphere, countries like the United States, Canada, and the United Kingdom enjoy their longest days and warmest temperatures. Meanwhile, Australia, New Zealand, and South Africa are experiencing their shortest days and winter chill. By December 21st, the scenario flips. The Southern Hemisphere welcomes summer and the Northern Hemisphere sees winter. This axial tilt doesn't just affect temperature but also influences the intensity of sunlight. When the sun is higher in the sky, its rays hit Earth more directly, concentrating energy and heat. When the sun is lower, rays spread over a larger surface area, leading to cooler temperatures. Thus, the tilt affects both how intense the sunlight is and how long it lasts each day. Of course, another important factor is Earth's orbit around the Sun, which is slightly elliptical, meaning Earth is not at the exact same distance from the Sun throughout the year. However, this variation plays a much smaller role in seasonal changes compared to axial tilt. In fact, Earth is actually closest to the Sun, a point called perihelion, around January during the Northern Hemisphere's winter. This demonstrates that distance alone doesn't cause the seasons. Besides temperature and daylight, the changing seasons have profound effects on ecosystems and human activities. In spring and summer, longer daylight hours encourage plant growth, blooming flowers, and active wildlife. These seasons are critical for agriculture, as crops rely on the warmth and sunlight to grow. In contrast, autumn and winter trigger hibernation in some animals and dormancy in plants. Humans have also adapted to these cycles, developing cultural traditions, festivals, and lifestyles around seasonal changes. Interestingly, the equator experiences very little seasonal change because sunlight remains fairly direct all year. Instead, regions near the equator tend to have wet and dry seasons rather than distinct temperature shifts. This illustrates that seasons vary not only between hemispheres but also by latitude. Understanding why seasons flip between hemispheres helps us appreciate the delicate mechanics of our planet. It also reminds us how life on Earth is finely tuned to these natural rhythms. Weather patterns, agriculture cycles, and even holiday traditions are all connected to the changing position of Earth relative to the Sun. In summary, the key takeaway is this: the axial tilt of approximately 23.5 degrees causes different parts of Earth's hemispheres to alternately lean toward or away from the sun as Earth orbits around it. This tilt leads to opposite seasons in the Northern and Southern Hemispheres. So when it's summer in your part of the world, it's winter on the opposite side of the globe. Thank you for joining this exploration into the science of seasons and hemispheres. Next time you notice the weather changing or hear about summer in Australia during December, you'll know why. A practical takeaway is that why seasons change between hemispheres matters because it affects real decisions people make every day. From a science perspective, results improve when measurements are checked consistently over time.